Hi, this video is about looking at stars through the Earth's atmosphere and the problems that that can bring. First of all, two keywords: transmit, which means photons are able to pass through something, and absorb, which means photons are not passed through. So photons get taken in, or they don't pass through. Now, there are a whole load of different waves in the Earth. There are some types of photon which can pass through the Earth's atmosphere and some which cannot. And so when we're trying to look at radiation coming from distant objects in space, then if we're looking through the Earth's atmosphere acts like a filter, allowing some things through and other things not. There are lots of graphs of this, but I'm going to just draw a very approximate version. So if you imagine this is the portion of the EM spectrum, so we're going in decreasing frequency as we go. Visible is a very thin band. Then we have infrared, microwaves, and then radio waves could be split up into a whole sequence, so we can have ultra high frequency and VHF, or ultra high frequency and very high frequency, and then we have long wave. So if we draw the graph looks something like this. X-rays and UV are largely absorbed by the atmosphere in the upper atmosphere, and then we have this spike where we can see the visible light. And then through infrared, there are certain frequencies which pass through and certain ones which don't. Then it drops down again, and we have not much. We have a small spike for some microwaves, and then it rises up again for UHF, and then drops down again for long wave. Now, this is the amount that passes through. So So essentially, the higher the graph, the more the waves can pass through. So you can see that when we look through the Earth's atmosphere, we're not going to be able to look at any X-rays or ultraviolet. We can look at visible, some infrared, some bits of microwave, and some bits of radio, and others not. Now, this is purely a function of the fact that the Earth's atmosphere will absorb certain frequencies of photon. So what it means is that most of our astronomy is taking place with these waves, so radio waves, visible, and bits of infrared. If we want to look at X-rays and UV, then we have to put our telescopes outside the Earth's atmosphere. So other effects that we get from space is the idea of stars twinkling. Now, stars twinkle because of the fact that there are different densities in the atmosphere. So as you're passing through the atmosphere, there are different densities of gases. So some areas are more dense, some are less dense. So as photons pass through them, they will get refracted and change direction. And because the atmosphere is in constant motion, because of convection currents, winds, etc., so these different areas of density move around, and what that causes is rays of light and photons to be refracted in different directions. So the technical term for this is scintillation, but if you think of it as twinkling stars. So that's another problem of looking at objects in the night sky through the Earth's atmosphere. So the solution to that, of course, is space telescopes. So space telescopes overcome all of these problems of selective absorption of different frequencies, but they do have their own issues. So on the plus side, there is no atmosphere in the way. So no atmosphere to worry about. Because there's no atmosphere in the way, we can look at all frequencies or all wavelengths of radiation. There's no weather, so there are no clouds in the way. Most telescopes on Earth trying to avoid this by being placed on top of very high mountains, so there's the least amount of atmosphere in the way as possible. So space telescopes have got a lot of advantages, but obviously the disadvantage is the cost, which is tremendous, such that one country on its own would unlikely to be able to do it, so it would have to combine with other countries. There is a risk involved in astronauts taking it into space, so risk to astronauts. Putting it up there because space travel is a very dangerous and precarious activity. The other advantage of space telescopes is there's no light pollution. So on Earth, street lights, house lights, etc., will cause light pollution, and you want the darkest place possible. Well, a very dark place would be in space, but the cost for building is huge. The cost for installing it, getting it into space is huge. And then the final cost, of course, which is maintenance. If something goes wrong with a space telescope, then that's billions and billions of pounds probably just to get it repaired. Whereas obviously when it's on Earth, it can be repaired more straightforwardly. Okay, so that's telescopes.